All right, welcome back. This is going to be Unit 2, and this is going to be Lecture 5 overall. So, we're going to be talking about energy efficiency in this chapter, right? And I'll try to take again sort of a higher level approach. Um, and basically, they take an economics definition of energy efficiency, as they would, I guess. And the idea is just to minimize energy input for every unit of output, right? So pretty basic economics definition. Okay, section 5.1.2, what causes inefficiencies, reasons for inefficiencies. One is just not using technology properly, right? And one major one that I would point out that I've read a lot about, sort of in not only energy economics and politics, but also sort of climate change research, is leakage in the pipelines that are used to transport liquid natural gas and petroleum products. Um, there's a lot of them, right? Because there's like hundreds of thousands of miles of pipes across the planet. And so it's really difficult to sort of maintain all of these different projects all at once. And so you get sort of a double whammy. I guess it's not an economic term, but you get the double whammy of sort of loss of product, right? Petroleum leakage or natural gas leakage, whatever it might be, but also the environmental damage involved in the leak at the area, right? And so there have been some really cool new projects from space organizations like NASA trying to figure out how to track leaks in pipelines using sort of chemistry spectrometry, I think is what it's called, where they're looking for leakages of like methane or things like that in pipelines, and they'll contact the maintenance company or the company that owns and try and get those things shut down. So pretty cool. Um, Okay, the second inefficiency is sort of an inefficient combination of inputs to produce a particular output, right? And so sometimes, say, like on a larger like grid perspective for electricity or something, there might be a particular logistical combination of, say, solar and wind, but also gas and coal, whatever it might be for a time being. That could be more efficient, right? Especially during times when it's very windy or it's summertime and there's a lot of sunshine out. We could sort of reduce the coal and power plant or the petroleum sort of creation of energy, right? And find this nice balance until we can sort of get that down and get renewables up over time, right? Um, I would say that here sometimes it's not about, say, logistics, right? The knowledge might be there, but the politics might not be. And so that can be a difficulty too, where not only sort of maybe politicians or a union from a particular like energy sector or particular industries will fight um, to reduce efficiencies from things like renewables so that they can keep control of the market, right? And so there has to be a good balance to try to figure out how to get over those political fights because sometimes it's not just about being able to analyze the situation, right? Okay, and then number three is employment of obsolete technology, right? So if you're using, this is one of the reasons that like they'll give you subsidies to get uh, 20 or 30-year-old combustion engine vehicle off the market and buy like a green car, right? Um, so that we can sort of take advantage of the efficiencies and the technology that has come over time, right? And so that I guess that would be like an example of obsolete technology. Section 5.2, measurement of energy efficiency. So this sort of just gets into like the science part of this stuff. Like what are some of the measurements we use across the industries? What are some of the measurements that like the scientific community uses to try and um, figure these things out like cross nationally, right? Comparatively. And then, like, in a moment, I'm not really going to talk much about it, but the sort of econometric modeling, right? Okay, so section 5.2.1 is about partial indicators. The first that they introduce is energy productivity, right? So the ratio of the output of a good or service to the energy consumption, right? And so, like, they tried to make it really wonky, but I would just say, like, a good example would be how many miles do you get per gallon in your car, right? This is energy productivity, right? My old 2001 pickup truck um, probably gets like 17 miles a gallon. It's not great, right? I wish it was better. Uh, versus some cars on the road right now that, I mean, yes, arguably the electric vehicles are at zero, right? I mean, they get infinite because they don't use gasoline. But you know, there are the smaller, teeny tiny little cars like the Europeans drive and stuff that'll get like 40, 50 miles a gallon. That's energy productivity, right? And we can sort of standardize um, um, how we measure that by giving a distance and an input, right? Okay. Energy intensity is sort of the opposite of that, right? The ratio of energy consumption to output. And so this is like kilowatt hours per capita, right? So that we can sort of compare across countries, right? Or maybe kilowatt hours per unit of GDP, like per $1 million or whatever it might be. Okay. The problem with some of these partial indicators, though, is that there are a lot of contributors that affect the variance, right? And so you're saying, well, here's this one measure, but there are a lot of things in there that don't really relate to like efficiency per se, right? Like if we're talking about kilowatt hours per capita, right? um, it's not only about like the efficiency of your cars or your factories or whatever it might be. It's also about like Canada uses less air conditioning than America does, and we use less than probably like Brazil does, right? Those sorts of things. How many extremely hot days do you get out of the year? What region of the world are you from? Um, does your population have access to mass transit, right? Or are you sort of a car culture like America? There are all these different sort of things that contribute to that measurement, that partial measurement, quote unquote, that aren't about like what they're trying to measure, right? So be careful about those things. Okay, section 5.2.2 is about econometric approaches, right? So this is what they taught me in grad school. One of my minors was in statistics and analysis, right? And so this is sort of the overall models, and this is what you learn in the what do they call it? The research design and analysis class with Taylor McMichael in our department. And so, yeah, this is just a way of us a way for you to measure a dependent variable, right? Like let's say efficiency. They're talking about like how far are you from that curve, your standard deviation from the curve in this chapter. So that's our dependent variable, and then you can plug in a whole bunch of things that you think contribute to that, right? Um, and so it allows you to control for those things that we know can affect efficiency and your distance from the minimum productivity curve, right? And so, generally, most research in the contemporary period is based on these sort of econometric approaches, whether logistics, binary models, or OLS regression models, or these sorts of things, right? Okay. Section 5.3 is about investment in energy efficiency. Um, I just kind of want to point out here, I'll let y'all read this stuff, but I want to point out here that corporations and governments tend to be better at this than individuals, right? There is a team of people who can analyze the cost benefit analysis, the future returns, the maintenance cost, inflation adjustments, all these sorts of things, right? And there's usually a big expenditure, right? Um, versus if I'm buying, I'm building a new house, say, and I want to buy new appliances like a dishwasher and a washer and dryer, right? Um, there are limits maybe to my purchasing long-term efficient cost-effective appliances that corporations don't necessarily have, and those can be cognitive, right? Like I just haven't done my homework because I have a lot more time constraints than a corporation or a government does, right? There also might be financial constraints, right? I'm already having to build a house, shell out all this money. I'm concerned about the final dollar amount, right? And so maybe I buy a cheaper appliance today that's going to cost me long term more, right? I would just say that like the sort of lower you get down the ladder, the more likely the the less likely it is that you're going to make one of these sort of assumed economically efficient decisions with full information and all of these sorts of nice terms that they put in there, right? And so yeah, individual households have a hard time with this, and this is a lot of times where sort of corporations and governments come in to provide the information to be able to tell you that look, it may cost you a little bit more upfront, but this is going to save you a lot of money on, say, your utility bill in the long run, that sort of thing. And so I wouldn't even say it's just the government's job, right? Like corporations that make these products that are well built and that save you money in the long term have an incentive uh, to to teach the public about those things, right? Okay. Um, let's see. Section 5.6 is interesting. It's about the rebound effect. This is just the idea that, like, all right, so you do invest in something that brings down the cost of energy, right? So now instead of paying, I have no idea what electricity costs, but let's just say, for assumption, instead of paying $1 per kilowatt hour, now I'm only paying 80 cents per kilowatt hour because my local utility provider, I don't know, made some technological leap, right? Well, sometimes instead of that actually leading to, less energy usage, it will lead to more energy usage because now it costs less. And so as a consumer, I'm like, hey, I can kind of splurge a little bit, right? And so there's almost that, what do they call it? The moral hazard idea sometimes that you have to be careful of too, right? Okay. I guess the last thing I kind of wanted to talk about here are sort of, they always have a little section on developing countries, and one of the problem with these efficiencies in developing countries, first of all, is they don't really say this, but you have to have access to power to be more efficient in your usage, and a lot of these people don't even have access, so they can't get you know more efficient usage out of it. Um, but there's also the problem of just credit constraints, right? And this was a lot of the research of this guy Amartya Sen, who won the Nobel Prize, I guess, in the tens at some point, 2011, 2012, for his work on sort of microfinancing. That is allowing some of the decentralization of energy in some of these sort of rural communities or tribal communities or wherever, whatever they might be, that don't really have access in developing countries, where they might have access to, say, some, I don't know, tiny little hydro energy system or along the local like stream, or they might have access to some very small like solar power kit in a tiny battery or something, right? They'll all sort of a lot of the locals sometimes will go in and share so that they can all like charge their cell phone or whatever it might be in the community, right? Um, but access to money is difficult, right? And generally, the way that these microfinancing loans work, which are one of the options here, is that only women are really given access, right? Because men apparently from research can't be trusted to sort of pay it back or spend it the proper way. So a lot of these sort of microfinancing loans are only given to women, And then a lot of them are sort of pooled together, like I was talking about in the community. Um, and then on the other side of these developing countries is some of the problems with sort of the payment systems, right? Not only are you many times providing a poor service that people are frustrated with because you're having rolling brownouts and blackouts, right? But often there's a lot of theft of the system because there isn't an infrastructure or a bureaucracy set up either between the corporation or the government to ensure that people actually pay, right? And to monitor the meters, to make sure there's no breaking into the meters, to make sure there's no draw from electrical wires in the area, all of these sorts of things, right? And so, I remember when I was a kid, it was famous. We lived in a trailer park, and a lot of like the neighbors would sort of uh, all wire off of one box to steal cable, right? And so you would see wires just sort of hanging from the cable box in the neighborhood. Yeah, and so it's that sort of thing in developing states too. Not only with like cable TV, of course, it was the early '80s when I was a kid, but with like electricity and things like that, right? And so it's really hard for these companies to understand sort of what their revenue stream looks like, to be able to reinvest into the infrastructure, all of these sorts of things. So, all right. Thanks for being here again. I'll see you soon. Have a great day.